so if, let me select the right window. So I'm going to close down a lot of that. I'm going to close down our discussion about Piazza. All right, I want to talk about understanding how to do C development, and there are a lot of very esoteric, strange parts of C. We've been talking about some of them with void stars and everything, but when you start debugging your code, you often end up with a lot of really weird problems that are compiler errors or are very strange problems when you try to link things together, or strange behaviors when you actually try to run your code. There are 10 million reasons why those could be occurring, but I want to talk about some of the preprocessor tricks that we use when we develop in C, and I want to talk about visibility and kind of scoping functions and data within C. Because these are things that it's hard to understand if you just look them up online, because there's a lot of resources and a lot of them are crap. So I think it's worth spending a little bit of time on this. So there are, what all of this revolves around is the idea that what I said before, experienced C programmers don't necessarily use all of the C programming language. Experienced C programmers restrict themselves to the behaviors in C that make sense and allow you to try to avoid shooting yourself in the foot, even though C gives you the gun to do so. You can do almost anything in C, but sometimes you really don't want to do everything. There are kind of mechanical ways to do this that often revolve around the notion of style, writing your code in a certain way that abides by style guidelines. I have a lot of links to style guides on the course webpage, and I wrote a big document that we use for our operating system that we develop at GW called the Composite Style Guide. That's my fairly long 20-page perspective on how to write readable and debuggable code. It will save you time in the long term if you internalize a lot of that, but I know from experience that not many people read it. Okay, so first let's talk about the C preprocessor. So I have generated a set of functions that again are going to be in the GitHub repo for all of this. That we will use to go through a few examples of some of the common problems and some of the common uses of the C preprocessor. So I have a number of files here, as you can see, and I have one from when I was testing this. I'm going to remove that. And I have a make file that kind of drives a lot of the compiler commands for this. Do not take this makefile, please, as a good example of a makefile. I attempted to make this as simple as possible so that it was as easy as possible to understand what it was doing without magic. In a future version of this event, hopefully I'll be able to go through a lot of makefile stuff. Okay, so what is this? Let's look at main. Main is a normal main. It includes your main function. In this case, I'm not including any fancy arguments or anything. I'm just taking void. I'm assuming that when you run this program, it will just run the functions within. And I have two functions that I can call, one lib1 function1 and one lib2 function1. That may actually be wrong, but we'll see. And I'm including two files, two .h files, two header files. One is lib1 and one is lib2. So let's see what those look like. So I have lib1 here. Very simple. All that lib1 does is includes lib2 and defines a function called lib1 function1, which we already saw here is being invoked, so that's fine. I'm going to talk about what all this junk is in about 15 minutes, so I'm going to avoid it for now. But we're essentially just implementing a very simple version of what this function1 could be, and calling a function within the lib2 library called function2. So let's actually look at what that is. So lib2.h. Lib2 doesn't include any other files. It includes its own things. It includes its own functions, notably function1 and function2. So if you look at lists, we're calling lib2's function1 here within main, and we're calling lib2's function 2 here within lib1. So hopefully it's a little apparent what's happening here. We just have a very simple call graph where main is calling something in lib2, something in lib1, and the lib1 header file also includes lib2 so that it can call its function. One thing that I want to point out here is that lib1 here does assume that it's going to call lib2's function 2. Whenever you're assuming within a file that you need a function defined within another .h file or in another .c file, you really should include the header file that's required for that here. So if you rely on something, you have a dependency on it, include the header file so that you know that this code will know what lib2 looks like. There are a few things that are happening when we include a .h file. We're essentially telling C, hey, this is what the type of that function is. So this function, lib2 function 2, it doesn't return anything and it doesn't take anything. There are no arguments. It doesn't really do anything, as you can see here, right? But for us to actually call the function here, C has to know what the type of that function is. So this goes to the core of what a header file is there to do. Thank you very much, Michael Scott, which is brilliant. I don't know if that's your real name. I haven't memorized all of your names yet, but Michael Scott, fantastic. So the point of a header file is generally to include all of the types of the functions that you need to call that might be provided by some other file. Programs get really complicated. The Linux kernel is multiple millions of lines of code, 50 million lines of code, whatever it is, and that needs to be split up into many different files that correspond to the different parts of the kernel, right? So we've been talking about in class things like the driver for accessing a SSD disk. So you'd better believe there's a .c file somewhere in the Linux kernel that corresponds to each of the SSD drives, right? So Winsau asked a really good question, is this like a package in Java? It's more like a class in Java, or a .java file, right? C doesn't really have a good notion of a package, a collection of these files. So .h files are a way for you to define a .c file in a function in a different .c file, and for another .c file to be able to call it. We are going to go through an example of that, so I don't want to go into that too much. I'm sure what I said right now is a little confusing. You can re-listen to it on the Twitch screen, but I am going to revisit that. Okay, another question, what's meant by static inline? As I said, I'm going to go over that in a few minutes. Okay, so this kind of is a simple enough program that it looks like it should trivially work. Like, we're just defining some functions that don't do anything, and then we're just calling them, right? So, like, high confidence this should work, right? Well, unfortunately, not so much. If we do make headers, because we're investigating headers now, we see that actually we have a number of problems. So make headers, we just ran a compilation command that looks like this. We just said gcc, I want to compile the main.c program, and I want you to generate a binary called main. It strictly is also saying, hey, any files that you're including, look in this directory. You can look at the man page for GCC for that. But, you know, this is a very simple compilation command. We have very simple programs. Why is this happening that we have these compilation errors? So we need to, of course, when C yells at us, we need to try to get into C's head, which is a very dangerous and terrifying place, and try to figure out what the heck it's doing, right? So first we say, all right, we're in a file that was included from main.c. If we look at main.c, we see that lib2 was included in main.c right here, and that's all that this is saying in main.c, in main.c on line 2 right here. we included this lib2.h file. Okay, fine. So now I know where it's seeing some sort of an error, and it's saying that I have redefined the lib2 function1 function. It's saying that, you know, that was defined here in lib2.h on line 2. So if I go to line 2 in lib2.h, I see, oh yeah, absolutely. So lib2 function1, yeah, it's defined there. Fine. What's the problem, C? What's your problem? So it's not done. It says, okay, so that's one. You're redefining this function. That's where it sees it defined here, and that's where it thinks that it's being defined twice. And it's also saying that in lib1.h, in main, we're including lib2.h. And lib2.h includes lib2 function 1, which we know it does. But for some reason it's saying main is including the lib2.h file, the header file, and it's seeing a function in there. Okay. But it's also saying that when we include the lib1 header file, it's re-including lib2. And because it's re-including it the second time, it's seeing two versions of lib2. This is confusing. Let's actually get into its head and see what it's doing. So let's go back to the shell. Oops. Wow. Let's not maybe do that, huh? Let's see what that looks like. So in our, let me go to the make file. Don't forget all the commands I made. So make pre-proc. So I made a make command here, and we can see what it's doing is GCC is doing the exact same operation. We're telling it to compile main.c, and we're telling it to output this file called main.preproc. Okay, that's weird, but yeah, whatever. And we're using the E flag here. E says, please do the preprocessor. So take all of those include files, run the preprocessor, and what that does is copy and paste anything that you're including exactly where you're including it. So we're running that, but we aren't necessarily compiling the file. Okay, so let's look at what C, when we run that preprocessor, include all of the .h files, thinks this whole thing looks like, right? So let's do a keyboard macro to find that, go to the start of the line, and kill the line, end the keyboard macro, and let's just do that for all of, okay, great. So I just wanted to clean up the thing, and then let's look at what that looks like in C mode. Okay, this is what C thinks the code we wrote is. And we see that we have this lib2 function. This was included from the lib1 header file, as was this. So all of this is, oops, I don't want the comment there, I want the comment there. This is lib2.h included from lib1.h. Okay, fine. This is the lib1 stuff, right? And it's really just this one function, right? And then we see this is the lib2.h contents included from main.c. And we see that we have this lib2 function 1 defined here and defined here. So what's happening is that C now thinks, because we've included essentially this lib2 header file twice, it thinks that we're trying to redefine that function, and that's a no-no. You can't define the same function with the same line twice. And this is just a simple main.c file. So hopefully this annotation of this file helps us get into C's head a little bit. The big problem is that we have we need to make it so that when we include a header file, we aren't including it multiple times. That's what the core of all of these problems are. So C provides a couple of means to do this. So when you have heard about header guards in either lab or in different places, that's essentially a way of just telling C, you know what, please just include this header file once when you're compiling a given compilation unit, a given .c file. So the problem is that lib2.h is somehow getting included, the contents of lib2.h is somehow getting included twice. So one way to get rid of that is to use a pragma called once. Pragma is just a nice way to tell the compiler, hey, there's this thing that I want you to do that's not really part of C, and in this case, I want you to include this .h file only once. So if we do that, and then we go back here, and of course I forgot the make commands already, make headers. And we run make headers, now it works, because we've told C, only include this lib2.h file once when we try to run the entire thing, right? So the whole idea here is add this line to prevent lib2.h from being included 2 times, right? That's the whole idea of what we're going for here, right? Why is my command not working? Oh, it's actually, okay, fine. Okay, this is one way to do to make sure that something is included only once. That's not what you'll see in a lot of C code, because this is the pragma thing is a newer thing. What you'll see in XV6 and in a lot of C code is what follows. This is a little mystic when you see it the first time. If not def lib1_h define lib1_h and if that. So this is a complicated way of doing the same thing. Let's run through what this is. Anything that starts with a % like this, that's a compiler directive, a preprocessor directive, right? So this is going to run in the preprocessor that runs before your C code is compiled. Includes are that. So include is just a way of saying, take the contents of this file and paste it right here, right? So pound, if not def, in if end if not defined, is essentially saying this lib1.h variable, if it's not defined, then do everything in between the if-def and the end-if. And all that we're going to do is say, all right, if that's lib1_h is not defined, then we're going to include all of this stuff. And the first thing that we do is actually define that variable. So now, because this variable is defined, if we were to include lib1.h again, we won't actually copy and paste all of this data into the .c file again. So this is a complicated way of doing this pragma once. You're going to see it in a lot of code, so I want to go over it here. I am not probably going to be able to explain it in a way that makes it completely obvious to everyone here. So please go through this example in your head after we're done here. So add the if and diff and associated commands to prevent lib1 from being included multiple times. Okay. Great, and for some reason that messed up. Okay. Okay, I'm sorry I'm not keeping up with the questions. So, does it need the if, end if, and the define? You got it. Here it is. You found the solution. So lib2 includes a function from 1. Absolutely. From lib1. Yes. Any particular reason to prefer one comment style over another? See my opinion on that in the composite style guide I referenced earlier. And is a little confused for the uppercase lib1. Yeah, so whenever you're using the preprocessor, you kind of just, whenever you're defining something, the convention in C is that things that are defined using the preprocessor are always uppercase and spaces are replaced with underscores. So this is just a C convention that you kind of run with when you're doing C. So this is preprocessor macros. I've also included some information about how to use the E flag to essentially output what the preprocessor is doing to your code, and we use that to debug the issue with the preprocessor macro here. I'm actually going to, because the makefile will overwrite it for posteriority, I'm going to save that to main preproc processed. I know that's a horrible name, so shoot me. Git add main.preproc.process. Great, done. Okay, so we've seen headers, and we've seen how to debug them to some degree. Let's go back to the plan of what we're going to be talking about. So we talked about header guards. I'm actually going to skip macros in general and how to use them hygienically. Google for macro hygiene and see if you want some information about that. I don't think you're going to really need it for this class. It's an important thing, and I might go over it later, but not now. It's a lower order bit. So the second thing that I wanted to go over, we have 5 minutes technically left in this stream, but I really want to go over this. So if you need to leave, that's fine. I think Twitch archives these things for about 14 days, so you can come back to it. That said, it's really important that you all are here physically with me, because all of these questions are absolutely fantastic. And we have 19 viewers. My God. I guess this is actually somewhat effective. You'll tell me in class tomorrow whether this is a waste of time or not. Okay. So next thing that I want to go over is another one of those really confusing things in C, and that is a lot of these modifiers like static, static inline, and extern, and what they actually mean. In Java, you control visibility in using keywords. So visibility in Java boils down to the keywords for things like private, public, and protected. The notion behind all of these, and I'm not going to go into the strict definition of these, so don't take this as a tutorial, I'm giving kind of a high-level overview here, is that private essentially means that if something is a field in a class is marked as private, it's only accessible within the class, right? So it's basically saying that that field is accessible only within the class. Public means that anyone can access it effectively. So somebody could say, you know, I have your object, and your field F1, if marked public, can be accessed directly. So, of course, a lot of our functions are public for classes, so that objects can have those functions invoked on them. And protected is a weird hybrid that takes into account a lot of things like packages and whatnot. I'm not going to go into that. But this is what we mean usually by visibility in programming languages. What code can access what variables? Because encapsulation is a very important aspect of what we do. Hiding the implementation details of what you do is important. We talked about this for the linked list example earlier. You don't want clients of an API reaching into your implementation and accessing things that you assume that they aren't going to access. So this notion of visibility is really important. In C, the unit of visibility is a C file. So the actual unit of visibility is C file. So what we actually say is which variables and functions can be accessed from which .c files. So that's how C imagines visibility. If we can access a variable that's global within another .c file, then it's the equivalent of public, and we have ways to do that in C. If you're implementing a .c file and you have some really important function that you don't want another .c file to be able to access, then you have a way to essentially make it the equivalent of private. So that's what visibility in C means, and that's what a lot of these static, inline, and extern type directives end up coming down to. And they apply both for functions and for the actual data that we have. So I just want to go into a few examples here. This is maybe a little bit easier to understand, I think, than the header guards, just because they're a really weird C esoteric thing. The include directive is much more primitive than import in pretty much any other language. It's also more powerful, which is kind of the definition of C. Horrible facilities for doing things that you want to protect yourself from, but really great at letting you do almost anything. There's a reason why operating systems are written in it, usually, or often, I should say. Okay, so let's look at two .c files. So if the unit of visibility in C is a .c file, then we need to look at two .c files to look at what that means. So now we have two .c files. I have my main on the right, and I have another .c file called more on the left. And let's say that I want to create a global variable in main, and I'm just going to keep it real simple here and call it x. I'm going to call it an integer, and let's actually initialize it to something. Obviously, if you can initialize something to the meaning of life, you always should. So 42 it is. So I now have a global variable. I know that when I'm in main, I can access x and everything is just hunky-dory, right? So I can multiply it by 2 and we're good to go. That's not a problem, right? The question is, if I have a function in my other .c file, can I do something like that? Can I modify x in there? So let's actually look at what happens here. So I have this. If I were to just compile, if I were to try to run this, it's not really going to do much because I don't actually have more execute ever. So I'm going to call the obj function within main to actually make that happen. Okay. So let's actually compile this and see what happens. I'll split the screen to make it a little bit easier to see everything. I hope that this compiles, so I don't need a whole bunch of screen space. Great. So make visibility. Now, of course it doesn't compile. Actually, because of the reason that I'm talking about. I should have been paying attention to my own words and my own machinations for how to actually run this thing. Okay. Why doesn't this work? It doesn't work because the visibility rules of C say that it's actually not allowed to work. So why is that? Obj function is essentially saying, here's an x that I'm trying to do some operation on, and here divide it by 2, and it doesn't know what x is. X is not defined in lib2, so it literally just doesn't know the type of x. So here it's saying in the make file that I have, okay, well I have another problem. I'm going to pay attention to this one here. So in more on line 6, I am referring to x, and x is undeclared, right? Okay, fine. So I can't just use a function in another file. I need to do something to be able to use it. One way to do that, and I would discourage anybody from doing this, I mean, you'll see this used in a lot of C code. I'm not saying it's not common, but you only want to use this function when you have to, is to use extern. Extern is a way of saying that in another compilation unit, I don't know which one, but in another compilation unit, in another .c file, there happens to be an x, and let's say that it has a type of int, right? I actually am going to do that same thing here with obj to make it so that we can call obj within main. So I'm going to say that obj function is extern. It is a function that is external to list compilation unit. It's in another .c file, right? It's somewhere else. In fact, it's in more.c. So let's see if this actually makes it work. So now we have the same problem that we had before, but for a different reason. I'm gonna just kind of fix this under the scenes because I don't care about that problem. And now it compiles. And if we actually try to run it, it, works in that it doesn't fault in some way. And it would actually go through and execute everything. However, the reason why you really, really, really do not want to use extern is because, well, what if I said that extern, that x is not an integer? What if I said that x is a float? So it's some sort of a weird floating point thing, right? Okay. Actually, I want to debug this properly, which is to say using printfs. So we're going to add, Jesus Christ, we're going to add stdio because that's how you get printf. And then after here, we're going to say, all right, let's take printf, and because I know above here that x is an integer, I'm going to try to print out a integer, always add, or I'm going to add the new line here, and I'm just going to print out x. So let's go through and make the thing, and then let's run the thing, and I see 42. This is what I'd expect. I multiply it by 2 here, and then I call obj function, I divide the value by 2, and then I multiply it by 2. So we're back to what it originally was, which is 42. Okay, great. Michael Scott, I'm sorry that I kind of skipped your question. I'm going to come back to that. The answer is yes. Okay, so we have our printf. We can debug this. Great. But I want to show you the peril of using the extern modifier. If we make, it works. I want to point out how wrong this seems. Here we're treating x as an integer. Here we're treating x as a float. Actually, I don't remember the IEEE layout of floats. I'm guessing this won't work, but I might be wrong. Let's see. It does work. Of course, bad example. So let's use instead a... let's make it interesting and make it a char. And then that's... I want to make this something weird. I'm going to make it something even stranger. I'm going to make it a void star. No, that's too weird. I'm going to make it a char star. I could do that. When you use extern, you just say what the type is. You say, yeah, I think x is a char star, so, let's make it a char star. And then I'm going to malloc it. I'm going to malloc 20. So I'm basically saying, cool, that x thing, that's a char star, I'm going to malloc some stuff into it. Awesome. No problem. Of course, I haven't defined malloc, so I should probably do that. It compiles. Again, that should feel wrong. It does something really weird because we're just treating it as a different type, right? So the core problem here is that because we used extern to basically say, you know what, I know there's this variable x in one of these other compilation units in another .c file. I know there is. Just trust me, see, it's okay. And I know it's of this type. Trust me, it's okay. So extern basically means that you have to get this right. You have to get the type right. And if you're modifying your code and you modify the type in one place, but you forget to modify it everywhere that you have an extern, well, welcome to horrible bug zone, right? So generally, that's what extern does. It lets you reach across compilation units, but I would strongly discourage anybody from using it if you can avoid it. Extern is one of those things that, just avoid it if you can. Let's go back to code that, is less horrible. Okay, so let's go back to what we had because it was much nicer and predictable. So we're back in a case where, we want to use X. X is defined in main. We're in more. How do we do this? Michael G. Scott said, for C files to be visible from each other, do they have to include the same header files? Generally, yes. So let's do that. Let's define this header file that we use for some shared variables. It's a bad name. Please name things better. But again, no. Pragma once. I'm writing a .h file. First thing that you would do when you create a .h file is add the header guards. So pragma once, great. What I'm going to say here, this is where it gets a little weird, is that here we want to say I have a extern X. I'm putting in the header file instead of in my more. So now if we include shared.h, and because that shared.h is defining variables that, or is defining the types of variables that are defined within this main.c, we need to include it in here first. And here we have a weird problem where x is undeclared. What did I do that's wrong here? This is unexpected. This was an error that I have somewhere. Did I save this? Yes, I did. Shared.h is included here. So what the heck is happening? Okay, apparently I just forgot to save it. Cool. And now we're back to predictable behavior. So the idea is the .h file is there to define the API, which in this case you can see includes variables, includes not just functions but variables. So .h files are there to define the API, which is all of the functions and variables and their types that are defined in some other .c file. So when we include our .h file, our header file, what we're essentially doing is saying, yeah, I want to use that API, and this current .c file that I'm writing, in this case the one that's including shared.h, it wants to use that API, so it needs to know the types of all of the things that are in the other .c file. So this allows us to access the X. Global variables are horrible. Global variables are bad. If you find yourself trying to access global variables within another .c file, you're again probably not designing your software well. So I would again kind of maybe discourage accessing global variables in this way. But if my main is there to actually implement some abstraction where I'm supposed to be able to get my X variable, then I might define a function for getting X. This might be familiar for anybody who essentially does object-oriented programming. Yes, define your field or your method for accessing the fields that are private. So here I might return X. Within main, I know that I have access to X. It was defined within main, so I can define this function that allows me to access it. Great. Now, that doesn't really help this more.c compile unit, this more.c C file, say, all right, I want to be able to call this getX thing, and I want to be able to get the value of X. So now I have my local value of X, and I'm going to call getX to get it. The problem is now that this will not compile. Oops. Compile, not run, because now our more.c doesn't understand what the type of this getX function is. So how do we inform it of that? Our header file specifies the entire API for this main.c thing, right? So what we can do here is in our header file for shared, we can say, hey, this is what our getX function looks like. This is the type of getX. Our shared.h file is included both in main.c so that it can check to see that when we actually define the contents of that getX function, it matches what's in shared. And we include shared here so we can actually see what getX looks like. So awesome. Now I can getX, and I can call that function because it was defined in the API called shared for the main file that we have. I'm actually going to make, I realize that I did a very stupid thing. I'm going to, whoops, main.h. I'm going to define the header file to be the same name but .h as the C file that it provides the API for. This is very typical. So I have main.c that defines the API that's supposed to be used by other .c files for functions within main.c. Now, of course, if I wanted to do what I had done before, then I would need to also have a set x. I would take my x variable, and I would take x and set it equal to x. So that allows us to set the variable. And if we wanted to make the program run again, as we were kind of expecting it to, then we go back to more, and we can do set x equals getx divided by 2. And let's see if I made some sort of an error. Of course I did, because that's how I do do's. Oh no, I didn't. I just didn't abide by my API rules. If I want setx to be in the API for main.c, I have to add it to main.h so that anybody who wants to use that API will see what the types are. So I add it in there, and all of a sudden, we're back to compilation, and we're back to hopefully something that's runnable and doing what we want. Operating system example 700. I love the anonymous username. Do we have to implement all the functions in the .h files whenever it is included in the .c file? Yeah. I mean, not strictly, but if you call the function because it's in the .h file, yeah, you better include it somewhere. If you don't call the function and you don't define it somewhere, that's okay, maybe. But, you know, eventually you're going to need to implement everything. If you're asking, while I develop, is it okay to have some of these unimplemented? The answer is yes. If you're talking about, in my final implementation, should I have, you know, the .c implementations of all these things? The answer is absolutely, you need those things. Okay, so it gets two more complicated, and then I'm going to call it quits. I'm sorry that this went so far over. Again, feel free to leave if you don't want to be here. No problem. In the .h file for the homework let's out, we require that you implement everything in the .h file, essentially. Your entire linked list needs to be in the .h file. So there is no equivalent of main.c. Instead, that entire linked list abstraction is implemented in the .h file. So whenever we do this, which is to say whenever we want to define a whole bunch of functions within a header file, we tend to have to use static inline. So what I'm going to do is define a function, I don't even know, just let's call it something dumb like double. It'll take an int, and I am actually defining the contents of the function, so I'm going to actually provide the code here, even though it's in a .h file, and what I'm going to do is just return x times 2. So I'm going to double it, right? So this is fundamentally different. I'm not saying within another .h file there are these functions defined. In another .c file, these functions are defined, and here are the types so that you can call them from another .c file. Instead, I'm saying here is the function, and you can call that directly. As we now know, this .h file is included. Copy and paste into wherever you have the pound define include or the pound include directive, right? So this static inline double is actually just kind of getting copied and pasted into the file that is including it. I'm going to avoid the static inline so that we see where some problems might actually be, okay? So if I were to just call this double on the value of x that we get, that, oh, well, you know, you can't actually use a function that's the same name as a keyword. So, you know, thanks for that. I made a mistake there. So times 2, let's make it something that's not a keyword. Thank you very much. So times 2. If we compile, if we run, well, it does something weird. That is actually confusing to me. That's not what I was expecting to happen. Does anybody see what might have gone wrong here? Did I make some sort of a dumb error? Oh wait, did I just double and then double? Yeah, okay. So let's do division here. So I just doubled and doubled. That was correct code, just not doing what I was expecting it to do. Okay, fine. So everything's fine. So I just told you, you need static inline. Yeah, but everything was fine. So what's the deal here? All right. Let's remove that. That's okay, great. Yeah, it's just visibility, and that compiles everything together. Right. So I want to get a little bit of introspection into what is... Oh, no. Okay, so something's wrong here. I was confused as to why an error isn't happening, because an error should be happening, and I think I just made a very stupid error. So in main, I hadn't changed it to use its own main.h. Okay, fine. So I want this to have an error. It better have an error. There we go. Sorry about that confusion. So if we properly use the header files and say, oh, this is main.c, let me actually use the proper main.h here. Okay, great. Now they're both including, both of our .c files are including main.h. So it's including this .h file twice, but separately into each of the .h files. That's a-okay. That's perfectly fine. I'll post in Piazza where all this is. However, when I try to compile the code, it doesn't have a compilation error. We're fine from a C perspective. However, when we try to compile both of these things together, we get a linker error. So this is a linker error. When I try to combine the two .c files together, I get that there are multiple definitions of times 2. So remember, when we include a .h file, what's happening is that we are copying, pasting this contents of main.h into both of these things. So what we're really doing is providing two versions of times 2 into the separate .c files. The problem is that C visibility dictates that if you define a function in a .c file that will be visible, i.e. kind of public in Java parlance, from other .c files. So what it thinks we're doing is actually defining times 2 as a function in both of these .c files, and then when we try to add them together, when we try to link them together into one executable, it kind of vomits, because it says, whoa, 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 you have two versions of this .c file. I don't know what to do about that. So let's actually see what that looks like. So I'm going to actually run GCC and run it separately on the two main.c. That is confusing to me. Oh yeah, well, duh. I need to not generate the actual thing. So this generates a .o file. So if I look at lists, I can see that there's a main.o file that was generated. That's an object file. Object files are just one-to-one to .c files. When I compile a .c file, it generates a .o file. That's kind of the binary for it. Fine. I can also compile my more.c file, and that generates a more.o So now I have two object files. So to understand a little bit how C is thinking about this situation, where I now have these two functions times 2 that are separately defined in the 2.c files, I have to actually see what is public, or the equivalent of public, and what's private in all of these things. And nm is a great way to do that. nm is a little program that will spit out information about all of the variables, all of the global variables, and all of the functions within a .o file. So here I can see, yes, here is a times 2 variable. Here's setf. Here's a main. All of these things are defined within main or exist within main. What's a little weird is that I also have obj function here. If you look at our code in more.c, obj function is actually defined in a separate .c file. Now you start to see what this means. This means this obj function thing, this obj function is undefined within our main file. So what C is going to try to do when it links the main together with the more is that it's going to say main relies on this obj function, but it's not defined within the main.c program. So it needs to find that somewhere. It's undefined within main.c. So when we link the two programs together, the two .c files together, it's going to then find the object function that is in more.c. And you can see that it also defines this times 2 thing. However, times 2 is not undefined. Times 2 is a T specifier here. T means that it is defined, and capital T means that it will be seen by other .c files. Okay, so I want to recap the important parts here. Capital T means that this function times 2 is defined within this main.c essentially file. Great. It's a capital T. That means that it's not just defined there, but if another .c file wants to use times 2, it will be visible from that other .c function, that other .c file, sorry. Now, if we look at more.o, we see that times 2 is also defined within more.o. And we know this because we're including the same .h file that includes the same implementation of times 2 in both of those .c files. So of course there are two versions of this. The big problem is that it's also visible to other .c files within more.o. And this is the core of the problem that we're seeing here. That main.o defines times 2, more.o defines times 2, and they're both public. So when we try to combine those two objects together into the executable that we want to run, the linker says, whoa, I don't know which version of those functions that you actually want me to use. So it spits out this error where it says that you have times 2 multiply defined. So this is where we start coming into, hopefully less clear. I know this is a lot. I am trying to be as terse as possible here, so you might need to follow through some of this. Yeah, I can run this. I can't run the, it didn't compile, so I can't run the program. But if I try to compile it, I get the linker error. This is actually saying that it can't generate the eventual output. It's saying that the function times 2 is defined both in more.c and in main.c. So it's saying that it's defined 2 times. Static is our keyword in C to essentially say, whoa, 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 I don't want this to be a function or a variable that is visible to another .c file. So when you have a variable that's global, when you have a function that you only want to be visible within a single .c file, you mark it with static and you're done. That's how you do it. So now if we try to do make visibility, yeah, we still have the problem. Did I forget to save. I added static in the most idiotic place possible. That's not modified the place that has a problem. So here we're in the .h file where we have the ×2 that's being included in multiple places. We're marking it as static, saying that no matter where this ×2 function is included, I only want that .c file to be able to see that version of ×2. This allows us to have multiple versions of ×2 and allows us to have the program actually work again. Now the weird thing is that if I were to now, and this is going to be a little bit more of a mess, I apologize. Now if I were to look through my object, so I used nm on my overall object that includes that's the executable that includes both my main.c and my more.c, I actually see that ×2 is actually defined 2 times, one for each of my .h files. But this compiles and it links because we have lowercase t's here, which means that in each of those .c files, that's a private version of ×2. None of the other .h files will be able to see it. So this is how we control visibility in C. In my main.c, I know that I wanted X to essentially be a private thing that nobody else could see. So let me mark it as static, and hopefully, hopefully everything still works. So static is our way to essentially say, you know what, this should only be seen from within this one .c file, within this one compilation unit. If you were to run this with warnings, which you really need to do, again, I pared down the makefile here, you'd see that you're gonna have something that, if you do static of a function, then it generally is gonna want it to be inline. I'm not gonna go into why that is. It's just a C thing. You don't need to worry about it, but it still works. So I'm gonna ignore that for now. So this is visibility in C. You can use extern to reach across .c files and access things, but you have to specify the type, and that's real dangerous. You might get it wrong, or the other .c file might change that type, and then nothing's going to work. So instead, we put in our .h files the shared APIs that are the client-facing APIs that other .c files use to access our functions. We mark those functions in the .h files. So let's go back to main.h. We put all those functions in here so that we have these shared types that we know both .c files will agree to, so that when we call the functions, it should work. And sometimes we use static inline to actually be able to define the contents of the functions actually in the .h file as well. This is usually a performance hack more than anything else, but in the initial homework I wanted to keep things simple and not have multiple .c files for you, so the entire linked lists are using static inline. So hopefully that's a little bit of an overview about visibility in C and some tools that you can use to debug it. So I hope this has been useful. I know this has been a lot, and this went drastically over in time. I spent an hour talking about all this stuff. So hopefully this is useful. Please tell me in class later. And I'm going to talk a little bit later, maybe next time, about conventions that we use for actually organizing our code, given how C looks at a lot of these things. So unless there are any more questions, that's it for the night. Thank you all for coming. I appreciate it.